Welcome to a new episode of our podcast, Alles DICHT. Today, we're talking about the future of sealing materials, innovation, regulation, and AI. There's a well-known saying, sealing technology is materials science. Today, we want to explore what that means in today's world. I'm joined by Professor Dr. Ruth Bieringer, Vice President of Technology and Innovation, Material Technology at Freudenberg Sealing Technologies. Since January 2026, she has also been an honorary professor in the Department of Engineering at Rhine-Main University of Applied Sciences. In addition, she serves as president of the German Chemical Society. She brings a unique perspective on materials science from industry, academia, and professional associations. Ruth, it's a pleasure to have you with us today.
Thank you for inviting me, Roger.
Let me start with a personal question. Since the beginning of this year, you've taken on several new responsibilities. Are there really no challenges left in the field of sealing materials?
Yes, of course there are. There always have been. And today there are more than ever. And I think we'll get to that as we talk.
I'm sure we will. But first, an honorary professorship in engineering. What does that mean from the perspective of sealing technology?
To be honest, sealing technology plays a rather minor role there. I mainly teach material science with a focus on polymers. Of course, every now and then I try to bring in an example from the world of sealing technology to illustrate certain concepts. But sealing technology isn't the focus of my teaching.
Okay, so that's true of a lot of fields where sealing technology isn't really taught at all.
Exactly.
Okay, so what are your responsibilities at the German Chemical Society? And what priorities do you want to set there as the president?
Well, I lead the German Chemical Society. Together with the Presidium and the Executive Board, I'm involved in its strategic management. And I also represent the society externally. One of my main responsibilities is to help drive scientific and societal initiatives. At the same time, we are continuing to develop the organization. It's about building networks and encouraging dialogue between science, politics, and society. And it's also about inspiring people to engage with chemistry and promoting high-quality education.
Well, I think that's an important topic for us today, because chemistry is losing ground in Europe.
Yes, and chemistry isn't sexy anymore. It is often seen as the problem rather than the solution. At least that's how it's perceived. But it's actually the other way around. Nothing works without chemistry. We won't achieve the energy transition. We won't find solutions to climate change. None of that will work without chemistry.
Yes, we'll have to work on that. But let's get back to our core topics. As you already mentioned, there are still plenty of challenges when it comes to sealing materials. What are they exactly?
Well, we probably need to make a distinction. On the one hand, we have traditional sealing solutions. These are continuously evolving to meet new requirements. At the same time, we're seeing entirely new classes of materials as we expand our portfolio beyond the sealing function itself. It's also important to look at seals in the context of material processability. Another area that's becoming increasingly important is regulation. This includes chemical regulations as well as other regulatory requirements.
That brings us back to the work of the society. As you said, it's a broad field. So let's take a closer look at the individual topics. Let's start with traditional sealing solutions. What are the main drivers behind the development of new materials in this area?
In the traditional sealing portfolio, the focus is primarily on long-term elasticity, as well as the abrasion and wear of rubber in sealing applications. As we expand our portfolio into areas such as e-mobility and hydrogen technologies, we're also dealing with completely new sealing media. These include battery electrolytes, liquid hydrogen, and ammonia as an energy carrier. As a result, the challenges have changed significantly.
Right, so completely new requirements are coming into play?
Yes, exactly. all of a sudden, we're talking about flame test. Seals now have to be more than just heat resistant. They may also need to provide electrical insulation, thermal conductivity, or even both electrical and thermal insulation. These are requirements we simply hadn't faced before.
Well, so that introduces a new element of multifunctionality, right?
Yes, of course. We're simply broadening our scope because the old applications aren't going away, but new ones are being added. The challenges in sealing are increasing. So, for example, with bus bars, we're suddenly looking into foams, which we had never done before, for example, in heat shields and thermal barrier materials.
Another point you just mentioned was new material classes. So what exactly do you mean by that, and how do they affect sealing technology?
Well, as I said, we're seeing a trend, especially in battery technology, toward high temperature resistant materials. So that means we're working with silicones much more than we used to. In general, we're seeing a major shift away from rubber and toward thermoplastic materials with properties different from what we've worked with so far.
So you just mentioned bus bars. We actually recorded another podcast on that topic with your colleague Parisa Berder. Just a quick note for everyone listening, we'll include a link to that episode in the episode description. It's a great example. So, will seals become increasingly multifunctional components in the future?
Yes, we are definitely seeing a trend away from purely sealing elements and toward multifunctional system components. But if you're asking whether the classic seal is becoming less important, the answer is clearly no. Traditional seals remain essential. They are still C parts, or rather C+ components, and they are here to stay.
But isn't that shifting?
Yes, of course it's shifting. And as a market leader and also as a company known not for being inexpensive, but for high quality, there will naturally be this shift toward multifunctional parts.
Okay, so earlier you mentioned another important aspect, manufacturing technology. We often hear that the manufacturing of seals doesn't receive the attention it deserves, even though it's a key factor in quality and value creation. Do the new materials and sealing solutions you've just described also require new manufacturing processes?
Yes, to some extent. At the end of the day, even the best sealing material is no good if it can't be manufactured in a cost-effective and reliable way, with as little scrap as possible. So as we continue to expand our portfolio, we're also introducing new manufacturing processes. As I mentioned earlier, we are now producing extruded foam materials. That's something we at Freudenberg Sealing Technologies had never done before, or only to a very limited extent. So these are completely new topics for us. Maybe not for the industry as a whole, but certainly for us. And right now, we're learning a great deal in a very short time.
So foam materials were already available on the market. It's a product line you've added to your portfolio. Does that mean you're mainly expanding your portfolio to meet changing market demands?
Yes. On the one hand, the requirements are changing, and on the other, we're a major supplier to the automotive industry. We know that part of our portfolio will disappear as the internal combustion engine is gradually phased out. We have known that since around 2016 or 2017. So we've been looking for ways to replace that business while continuing to grow.
Sure, we have to adapt to this development now, because the path toward electromobility is already mapped out?
Yes, exactly.
When we talk about manufacturing, availability is another topic that comes up again and again. We've seen just how important it is over the past few years, with the pandemic, supply chain disruptions, and, more recently, the situation in the Strait of Hormuz. What would you recommend companies do to deal with these kinds of challenges?
Yes, so that's obviously the key question. I think there are several aspects to it. On the one hand, of course, there's procurement. We have a strong network of strategic suppliers, and our procurement team is doing an excellent job. But we also need to diversify. In product development, that means relying more on dual sourcing, knowing our supplier portfolio inside out, and identifying suitable alternatives at an early stage, even if that means investing a little more time upfront. In other words, we need a backup plan so we can respond quickly whenever a supply bottleneck arises.
You mentioned earlier the importance of the chemical industry and the challenges it's currently facing. We are already seeing parts of the chemical industry move to other regions of the world. There are plenty of examples of that here in Europe. So, doesn't that make the supply situation even more challenging?
Yes, initially it does mean that more raw materials will come from other parts of the world. The key question is, will that create greater dependencies? Will it increase uncertainty? There's no simple answer to that. It really depends on the specific situation. And not everything is moving to China, but a significant share is, and that, of course, brings its own challenges.
Yes, so you just mentioned raw materials. That's another area where we are seeing major changes, especially when it comes to sealing materials and their formulations. We often hear that even small changes in raw materials can have a significant impact in practice. Could you give us a specific example?
Yes, that happens quite a lot actually. With such a broad portfolio, we often use the same raw material in many different formulations. Those formulations then end up in a wide range of applications for many different customers. And every now and then, something just doesn't work out as expected. A recent example is part of our FKM portfolio, our fluorocarbon rubber portfolio. We had to reformulate it because one of our suppliers changed a processing aid. So they didn't actually change the product itself. They only changed an auxiliary material used during the manufacturing process. Even a change like that can create a surprising amount of work. The basic chemical and thermal properties stay the same, but we still see differences in processing. As they say, the devil is in the details. At one production site or another, something suddenly doesn't work quite the way it did before. And that's when we have to step in, adjust the formulation, adapt the process, and make sure everything works reliably again.
That brings us to another topic you mentioned earlier, regulation, and of course the planned PFAS restrictions. We don't want to go into that in too much detail today, but it's already driving major changes across the industry. So what role do regulations like these play in driving innovation in materials engineering?
That's an interesting question. So I think regulations play a central role today, and their importance is growing all the time. On the one hand, they set clear boundaries, but on the other, they're also a real driver of innovation. Innovation today isn't just about performance anymore. It's about performance and sustainability, if you see regulation as part of sustainability. And I think that's exactly how we should look at it. Regulations aren't there to make life difficult. They're there to make our lives safer. That's why we genuinely welcome these developments. So yes, they mean extra effort and extra work, but they also give us the opportunity to differentiate ourselves from other companies and our competitors.
You just mentioned that regulations aren't there to make life difficult. So last year there was quite a bit of discussion about whether sealants and adhesives should even be classified as advanced materials under EU regulations. How do you see that debate, and why do you think their status is suddenly being questioned?
Well, I think the term advanced materials is a bit difficult. What exactly is advanced and what isn't? I would say that many of our standard materials, which have been serving us well for years or even decades, are advanced materials too. Or at least they were when they were first developed. That's exactly why we've been able to hold our own against the competition.
Okay, so for you it's completely clear. These are advanced materials, and the discussion is actually unnecessary?
Yes, that's right.
Great. So that could lead, for example, to good chemical regulation. That's the foundation, after all. And what would that look like, given the various positions you hold? And what would good chemical regulation look like?
Well, that's another tough question. So I think chemical regulation is always about finding the right balance. After all, it's there to protect people and the environment, and that's incredibly important. We all want clean drinking water, a clean environment, and clean air. At the same time, it shouldn't hold back innovation or industrial competitiveness. It also shouldn't regulate more than necessary. It should be science-based, risk-oriented, and still leave room for innovation. That's what good chemical regulation looks like to me.
That means this shift from a risk-based approach to a hazard-based approach would actually limit innovation?
Yes, I'm a strong advocate of a risk-based approach, and I don't think it makes sense to regulate something simply because it could be dangerous. It should only be regulated if it actually poses a risk to people or the environment.
That's true. And in many cases, it's something the chemical industry has been managing for centuries.
Exactly. And what's manageable doesn't need to be regulated.
There's another topic I would like to touch on: artificial intelligence. Just as with regulation and other complex challenges, there are high expectations for AI. How do you see the opportunities, and perhaps the risks, of using AI in materials development?
Well, if you ask me, AI's biggest strength is that it can shorten development cycles. So in other words, fewer physical tests are needed. It's about prediction instead of trial and error. The long-term vision, the one you often hear about, is inverse design. You define the target and the AI suggests suitable materials. So I think we are still quite a long way from that. When it comes to rubber, we always deal with multi-component compounds. A typical rubber compound contains 7 to 15 different components. And the media we are sealing against often consist of many different components as well. That's still a real challenge for AI today. On top of that, the data we currently have isn't yet sufficient, either in terms of quantity or quality, to provide a solid foundation for AI. So I think that's one of the areas where we need to make rapid progress.
What kind of data are we missing today?
Well, we are already seeing in our AI pilot projects that we reach the limits quite quickly. One of the biggest challenges is data comparability. Another is connecting data across the entire process. What we really need is end-to-end data, from goods receipt through every step of the production process, all the way to product testing and validation on the test bench. And unfortunately, that's something we usually don't have today.
Well, the data was collected back when AI wasn't even on the radar?
Exactly. We have a lot of data silos. In other words, we have plenty of data, but it's not connected.
AI isn't just being used in materials development anymore. It's also increasingly being used to select materials and define sealing solutions. How do you see that development from the user's perspective?
So I think AI predictions will always need to be validated. In the end, we still have to test things. AI will help us work faster, reduce the number of tests, and perhaps even develop smarter and more efficient testing methods. But it won't replace testing altogether. Part of that is simply due to liability. What AI will probably be able to do in the near future is provide a kind of virtual pre-validation. That's what's known as shift left. We generate many different variants at an early stage and evaluate them upfront. That allows us to narrow down the options much more quickly and focus on the most promising materials. I also see great potential in so-called hybrid models that combine physics and AI. For example, by integrating traditional FEM with data-driven models. I believe that's where we'll see the greatest impact.
I would like to come back to the user's perspective for a moment. Earlier, when we talked about your work at the university, you mentioned that your focus isn't just on sealing technology, but on materials science as a whole. Our surveys repeatedly show that in many companies, the expertise needed to properly design sealing solutions is often missing. As a result, more and more people are turning to AI for support. Doesn't that also create a risk if users aren't able to properly assess or verify the results? That could have a direct impact on your work.
Of course. As I said, AI will always need to be verified and validated. We can't simply rely on AI. We are nowhere near that point yet. So AI can make suggestions, but in the end, people still have to review them, evaluate them, and make the final decision.
Based on what you've just said, my takeaway is that we still need a great deal more expertise and, above all, much better data. Does that also mean we need more basic research in materials science to provide the foundation for all of this?
Yes, that's a good question. So first of all, we would have to define what we actually mean by basic research. Who does basic research? Is it industry or is it mainly the universities? I would say it's certainly the latter, at least to a large extent. A lot of research is carried out at universities, and that's where many discoveries and innovations originate. The real challenge is transferring those innovations into industry. That's where we often run into a bottleneck. Part of the issue is risk financing. We do have a vibrant startup ecosystem in Germany, and new companies are being founded. But there's often not enough venture capital to really get those ideas off the ground. In my view, that's one area where Germany still has some catching up to do.
So that situation hasn't really changed. We often hear that industrial companies simply acquire startups and integrate them into their own organizations. Many of those startups are university spin-offs. But from what you're saying, that doesn't really solve the underlying problem.
Well, it's probably the only way. So I just think there are countries that do this much better than we do.
Yeah, well, the startup culture in Germany is just what it is.
Yes.
So let's leave that topic there for now. If I were to sum up our conversation, it seems that sealing technology is, to a large extent, still all about materials. Looking ahead, what would you say are the 3 key areas we should focus on?
So I would highlight 3 areas. First, high-performance materials that comply with regulations and have secure supply chains. Second, multifunctional material systems rather than traditional elastomers. And third, what I would call predictive materials. In other words, combining lifetime prediction with prognostics supported by AI.
Okay, those are the technical aspects. We still need people to do this, and they're getting harder and harder to motivate, right?
Yes, the sealing technology isn't exactly sexy either.
If it's such a fascinating topic, why isn't it considered sexy? Is it being marketed the wrong way?
Well, first of all, it's invisible. And secondly, it's competing with all the big buzzwords, pharma, climate, high-tech, electronics. So you really have to explain why it's such an important field. But there are definitely ways to get people excited about it. The technology is becoming more and more sophisticated, and its importance is continuing to grow. It's also a truly interdisciplinary field. In sealing technology, you can only succeed when chemistry, engineering, and data science all come together. So, in my view, sealing technology is actually a fascinating field. I have been working in it for 26 years now, and I can honestly say that not a single day has ever been boring.
So I can imagine that. I mean, I can see it a bit from a media perspective too. It's great to see all the topics that come up around it.
Yes, and it has great societal significance. Of course, that's not always apparent, but we know how important sealing technology is.
We need to make it more visible. Looking ahead, if we were to meet again in 10 years, what do you think will have changed in materials development for seals and for the people working in this field?
That's a difficult question. So I think the way we work, the methods we use, will certainly continue to evolve, and not just because of AI. But overall, I'm not sure that the fundamentals will change all that much. In the end, it still comes down to having well-trained people with good ideas, people who understand their customers and understand the market. We'll also need the right raw materials, a broad portfolio, and reliable supply at competitive prices. And we'll need process engineers who continue to develop smarter manufacturing processes. There's also still plenty of potential in automation to make production faster, more cost-effective, and ultimately remain competitive.
So the fundamentals won't really change. It's more about people working together more closely and taking a more holistic approach.
That's a good summary. And above all, people have to do it together. So I think that's the key point.
Yes, because that's often the problem today. By the time an issue comes up, people haven't been working closely enough together.
Exactly. Then the interfaces don't fit together, or you end up with silos that don't communicate with each other. The problem simply hasn't been looked at as a whole. I see it the same way.
Well then, thank you very much for your time and for the interesting conversation, Ruth.
Yes, thank you. It was a lot of fun.
I couldn't agree more. And thank you very much for listening to Alles DICHT, the Iskatech podcast about sealing technology and polymers. If you enjoyed this episode, please subscribe to the podcast and share it with your colleagues and network. Thanks for listening, and we'll see you next time.